So here we're going to be calculating the Vasicek model, and the Vasicek model measures the extent to which interest rates mean revert to their average. The equation for the Vasicek model is shown here, where dr represents the actual change in the interest rates, A is a guess for the mean reverting speed, B is the long-term mean, and sigma d2 is the standard deviation on a random element in the model. In column H, all we did was convert the value in column J to a percentage, and then in column I we just minus the second figure here from the first figure, from the first quarter of the year 2000. Here you can see the pre-solver parameters, which are the guesses, and in column J we calculated the fit based on these initial values for A, B and the volatility. The guesses are unlikely to be true, so we have to get a maximum likelihood technique, and to do this we have to find the standard error. Next we just minus the figure in column I from the figure in column J, and next we have to calculate the PDF. So we select the parameter inputs that minimize the error from column J, and to do this we set out a probability density function using the norm dist function, and using norm dist we identified the values from column J we want to set to 0. In other words, we want to make the difference between the actual and the fit equal to 0. We reference the standard deviation, the volatility, and then we determine the probability density function, which is false. So essentially in the PDF we are trying to select values for the Vasicek model that gets us as close to as possible to 0. In other words, we are trying to maximize the probability density function. Then in column O we take the natural log of each PDF, and then we sum these figures together, which is shown in column B11. Then we calculated an optimization table that gives us values for A, B and volatility, which are shown here. That minimizes the error, in other words the difference between columns H and columns I.